Hi, I'm Brendan, and today we're going to be talking about linkers, and more specifically, we'll be talking about symbol tables and relocation tables. But before we get into that, let's talk about linkers and why are linkers even important. Well, let's think back to project 1A when you wrote an assembler that broke down some assembly code into its machine code. That's very useful, but what happens when we run into the case where we want to include multiple C files, or let's say that we have a C file that references functions that were defined in another library. For example, printf. You didn't write that printf function. So how does your code know where to go, where to look? So that's why linkers are helpful. So basically what linkers do is it's able to combine these multiple, what are called object files, which are basically expansions on the machine code file. And it combines them in such a way that now a simulator or some sort of execution will know where exactly it needs to look to find different functions and different data. And so the way that object files differ from machine code files is summarized pretty nicely here in this diagram. And so the examples that we reference mostly in class are what are called Linux elf files. And so those are just Linux versions of object files. And so there's a few different sections. The first three are things that you might be able to understand a little bit more intuitively. So first off, for example, the header, all the header that contains is just the size of all of the following functions. So header's not too bad. And then text and data are also fairly intuitive because text is what stores the actual machine code of a specific C file. And so the text would be similar to the output you might see from what you wrote in 1A. Now data, you could think of data, if we're continuing with these analogies to LC2K, you could think of data as maybe those .fill statements that you would have at the end of an assembly program. If you're thinking in terms of C, you might have maybe some global data stored in this section. Then we have our symbol table and relocation table. We'll get back to those in just a second. At the end here, we just have some debug info depending on how you compiled your C file. Nothing really crazy or too interesting going on down there. But now let's take a look back here at the symbol table and the relocation table. So remember that this elf file is per C file. So basically every single piece of C code that you would be compiling, every file, is going to have its own elf file. And so what that means is that each file will also have its own symbol table and relocation table. And so what these do is these accomplish that merging that I was talking about before. So anytime, let's say that you want to call printf, so your program will recognize that, or a compiler would recognize that printf is an external symbol, and so it would know that it needs to basically fix up that address when it's linking them back together. And so there's a variety of things that we need to go in a symbol table and a relocation table. Just a non-exhaustive list, but some examples would be calls to functions in other files, using data in other files, or using global variables, static variables, string literals, etc. And so all of these different references need to be fixed up by entries in the relocation table. And the symbols themselves, these references to other files and to global variables, those are what are called symbols, and that's what goes in the symbol table itself. So let's consider just a basic example here where we have these two C files, and we want to figure out what would it look like if we needed to put some of these entries into the symbol table and into the relocation table. So let's break this down. So let's start off with main, and specifically let's start off with main's symbol table, and let's check out what we think would go in there. So let's walk line by line. The first line we see hashtag include, and this is referring to the standard input-output library for C. So include statements don't actually go in the symbol table or the relocation table. Those just sort of give us a good idea, and it gives the compiler a good idea of where it needs to look for certain functions, but again, not in either of these tables. But now we see lines 2 and 3, we have two externs. So we have an extern int bar, so that's referring to an external function, and then we also have extern int dec. And so what that means is that we're going to have these externals, that's what extern means. We're going to have these external symbols that are defined somewhere else in another file. So those would both go in the symbol table. So let's put under the label in the symbol table, we'll put bar, and we'll have dec. And so now in our type column, we would either put text, data, or undefined. And so a text would be a function declared within the same file. data would be data declared within the same file. And undefined is anything that's declared in another file. Even if we can pretty intuitively see that dec would be data somewhere else and bar would be text somewhere else, we would still just call that undefined. So for type, let's put U. And sometimes in symbol tables, you might see a third column that would be maybe like the address. And so for undefined, that would be like a not applicable field. But for text and data, we would try to estimate where within those sections that the symbol itself would be. We're going to skip that now just so we can focus on the important details. But just bear in mind that you'll often see that third column there in symbol tables that specifies the offset. So now next we see that we have int main. And so now main is a function that's declared within the same file. And so that's a symbol that would be in the text field. So we'd say main is our label, and then the type is text. Next off, we see a char star output. And then we assign that output to a string literal. So of course, output is just a pointer that's on the stack. But the little bit confusing thing is the string literal itself. So string literals, if you think about it, those have to be declared somewhere, right? Like we can't just like magically have these string literals that can be referenced at any time. And so where these string literals are actually stored, the convention we go by is that these are in the data section. And so we have string literals, and we want to put those string literals in our symbol table and say that those string literals are in the data section. So first we see that we have hey there, and so that would be what we would call our label. And then for the type there, we would call that data. And so you can just think of hey there as like this piece of data that we need to reference from time to time when we are actually accessing the output variable. Next, we see that we have static int num. And so a static variable is also something that we would store in data. So num would be a label. And num is of type data. Okay, next, int I equals 5. That's just a stack variable local to this file, local to this function. So we don't need to worry about that. And then we see that we have a while loop using that stack variable. And then we see that we have a decrement of that stack variable. Again, those are all fine. And then we see that we have on line 10, int temp equals bar of num. And so now we see that bar, again, is a reference to this external int bar function. But remember, we already put bar into the symbol table. And so in the symbol table, we only need to list each symbol once. So we're not going to repeat ourselves here. Next, we see a call to printf. So printf is a function that is declared externally, so we would want to include printf in our symbol table. So, of course, we know that printf is a function, but again, we don't call it of type text, we would just say it's undefined because it's in another file. And now lastly, we see that we have another string literal within this printf, and we see this %d new line. So this would be data within our file, and then the label itself would be the string literal. Okay, so that's main symbol table. Now let's check out what the relocation table would look like. So again, going from top to bottom, these first 3 lines here, these are, you can think of them as the declarations of the externs, but we're not actually using them in any sense. We're just sort of like defining them. So we don't really need to do any sort of relocation here because we're not actually using them. So relocation tables focuses more on the actual uses of the symbols. So now, again, same thing with int main. We're not actually calling the main function, so we don't need to worry about putting that in the relocation table. But now we see here on line 5, we have this char star output and we're assigning it to hey there. And so remember, hey there was something that we put in the symbol table in the data section. So it has the potential that it will need to be fixed up, this address. And so this is a little bit confusing of a point and is very specific to string literals. But what we would actually want to do on this line, on line 5, we have this dependency of our string literal. So we can write hey there. And the confusing part is this instruction type here. So since it's in the data section, it's very tempting to say we would want to load this entire string literal and load it into this char star output. But the thing with string literals is that these are still just pointers. So this char star output, all it's going to do is it's going to point to this location within the data section where this string literal is stored. So instead of saying that we're loading this string literal, all we're doing is we're changing output to point to that string literal. So we would actually call this a move, because all we're doing is assigning the output pointer to point to the string literal. We're not actually loading the data, just looking at the address, the pointer. And so that's, again, something specific to string literals. It is more specific to how C strings are actually working under the hood. Okay, so that's line 5. Next, we see static int num is equal to 7. And again, this is like another tempting case where we might want to call this a store, but this actually wouldn't be a store instruction because this is just an initialization. And so since we're setting static int num equal to 7 on its initialization, this is something that would happen like before the program even runs, or before, not before it runs, but it's something that we wouldn't have to worry about in the linking process. It's in the initialization. And then we see in I equals 5, again, stack variable, don't have to worry about it. And same with line 7 and 8, just something on the stack. And now we see on line, where we're at line 10 here, we see int temp is equal to bar of num. So we have two different things going on here. First, notice that we have num, and so num is referencing our symbol here, static int num. And so we're going to have to be able to fix that address up. So on line 10, we would see that our instruction would be a load, because we need to load the value within num as this parameter. And then the dependency we would say is num. And now we have our function bar, also on line 10. And so since this is a function call, our instruction type would be a branch. So just for abbreviation, LD for load, BR for branch. So that's line 10. And now lastly, line 11. We have two more entries here. And so things we've talked about before, we see a string literal, again, really just putting this pointer into this function. So that's a move. And then the dependency there is the string literal. And then lastly, another function call to printf. And that's also a branch. So this is what the symbol and the relocation tables would look like for the object file that is generated for this main.c code. And so now lastly, let's go over what the symbol and relocation tables would look like for bar, or bar.c more specifically. So we see at the top we have int dec equals 1 and int multiplier. So these are both global variables that we need to go in our symbol table. So we have our labels dec and multiplier. And so these are both defined within this function. Either of them are externs. So we would say the type of both of those is data. And then we also see that we have our function int bar. And since that's a function that's defined in this file, that would be text. And we see that those are the only symbols in this particular file. Int num is a parameter that is local to bar, nothing we have to worry about for a symbol. And now lastly, for the relocation table, looking at things we would have to relocate. So now we see this case, line 5, where we're setting multiplier equal to 4. So this is not a value that was assigned upon initialization. This is a value that was assigned after initialization, after multiplier was defined. And so in this case, we would need to store. So we would say that on line 5, we have a store, and that dependency is multiplier. And then lastly, on line 6, we return num times multiplier. And so num is simply a local. It's this parameter here. But again, multiplier is this global symbol, and now we're using this value. So we just stored it here, and now we're going to load it. And so then that's on line 6. And again, just using multiplier. And so that's it for bar.c, a lot simpler than main.c. Hopefully now you have a better understanding of what symbol and relocation tables are and how you might want to go about constructing them.